Aloha class, this is exercise 8-17, direct material and direct labor variances. Dawson Toys Limited produces a toy called the Maze. The company has recently established a standard cost system to help control costs and has established the following standards for the Maze toy. Okay, so we have our standards: direct materials 6 microns per toy, so their direct materials are measured in microns, and it costs 50 cents per micron. Direct labor 1.3 hours per toy at $8 per hour. Direct labor standards. During July, the company produced 3,000 Maze toys, so I put 3,000 at the top of my equation because that's what they're producing. Production data for the month on the toy follow. Direct materials, 25,000 microns were purchased at a cost of 48 cents per micron. 5,000 of these microns were still in inventory at the end of the month. So this is where you need to be careful with your direct materials price and quantity variance. So price variance is calculated on the total entire amount of purchase, but quantity variance is computed on the number of units, not the number of units, the number of direct materials used in production. So there's still 5,000 microns left in inventory. So if they started with 25,000, they still have 5,000 left over. They must have used 20,000 microns in production. So your quantity variance should be calculated on that 20,000 microns, while the price variance is going to be calculated on the 25,000 microns purchased. So again, price variance on the purchased amount of microns, and quantity variance on what they actually use in production, which is 20,000 microns. So I'm going to lay this out so that we can compute our materials price and quantity variance. So A, S, and then QP. Give me a second to get these in here. E, Q, P, Q, P. So this is our price variance over here. I can write that on top. Over here. And remember, we're going to break up this formula because they're purchasing a different amount than they're using in production. And now I'm going to use this side for my quantity variance. Okay. So I have my formula set up here. I'm going to use the left side of my equation, and I'll put in my standard price and my actual price. The standard price is 0.50 per micron. Actual price, they told me they purchased a cost at 0.48. Okay. Actual quantity, they purchased 25,000 microns and 25,000 microns. Okay. And now I can calculate this together and compare for my price variance. So 25,000 multiplied by actual price, they paid $12,000, 25,000, and they should have been spending 50 cents. So they have come in under budget. When I subtract 12,000, subtract 12,500, it's a negative number, which means they're coming in under budget. So I'm not going to put negative, I'm going to put 500. I'm going to put favorable. So they should have been spending 50 cents. They got a discount. They negotiated a deal that maybe it was a bulk discount. Or they were just really good negotiators. That could be a reason for this $500 favorable price variance. And now, this actual quantity, be aware that for quantity variance, it's calculated on the quantity used in production. So they still have 5,000 left over. They started with 25,000. They still have 5,000 left over. They're using 20,000 microns in production, like I was saying before. And same standard price, I'll just copy down that standard price. And standard quantity, they should be using 6 microns per toy. And I wouldn't want to compare 6 microns per toy to 20,000 total microns used in production. So they are producing, I'll move this down a little bit and maybe zoom in a little bit. Here it goes, there's the zoom. Okay. So they're producing, how many toys are they producing? They're producing 3,000 mazes. Maze toys. So to get this on a total number of microns they need, I'll multiply 6 multiplied by 3,000 maize toys. And that looks a lot closer to 20,000 microns. It's 18,000 microns. That's the standard that they should be using. They actually use 20,000, so it looks like they're going to have an unfavorable quantity variance. And let's calculate that quantity variance. Put this on. Yeah. So actual quantity multiplied by standard price, and standard quantity multiplied by standard price. And they are going to have a 1,000 unfavorable quantity variance. So what could have caused this quantity variance? Maybe you have an unskilled worker. Maybe you had wastage, excessive wastage. Maybe the quality of the product was poor, and that could be why you needed to use so much of it. There could be many different reasons for this. So we'll go to the textbook just to get a more precise reason. The textbook solutions say that an unfavorable quantity variance could be caused for a variety of reasons: poorly trained or supervised workers, improperly adjusting machines, and defective materials. A materials price variance, so we had that materials price variance before, was 500 favorable. Why would you have a price variance that's favorable? Well, you could have bought an unusually large quantity, taking advantage of quantity discounts, a change in the market price of the material, or particular sharp bargaining by the purchasing manager. So that could be a reason for that favorable and unfavorable, because the last question says, prepare a brief explanation of the possible causes. So we've explained those quantity and price variances, why that could happen. Let's move on to our labor rate and efficiency variances. So I'm going to do this similar formula: A, S, 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 and then we're going to do H, R, H, R, H, R. H. Okay. So now my standard rate is $8 per hour, $8 per hour, and it said 1.3 hours per toy, 1.3 hours per toy. Remember, we're still making those 3,000 maize toys. So these are our labor, direct labor. And I'll merge this, okay? And based on 3,000. So I want to convert this to a total number of hours they're going to need for all of the 3,000 maize toys. So I'll multiply 3,000 maize toys multiplied by 1.3 hours per toy or per unit. And standard rate is still $8. Now, how much did they actually pay their laborers? 4,000 direct labor hours were worked at a cost of $36,000. So I wouldn't do a rate of $36,000. They're not paying their workers $36,000 for every single hour. That's on a total basis. So they worked 4,000 direct labor hours. How much was the actual rate per hour? I will need to work backwards. Hopefully you can see this. I'm going to work backwards the total, and I'm going to divide by the hours worked. And that seems a lot similar to $8. They paid them $9 per hour. Actual hours is still 4,000. Okay, so I've calculated this side. I'm going to do my rate variance between the standard rate and the actual rate. So I'll multiply 4,000 multiplied by $8. And they should have been paying their workers $8 per hour. They paid them $9,000. So you're paying them more than the standard says you are. And that would be unfavorable. I'll give you a positive number. So this is unfavorable, $4,000 unfavorable. And let's do our efficiency variance. 3,900 multiplied by $8. And we'll take the difference between these. You also have an unfavorable, let's see, this one, subtract that one. Oh. This number, subtract that number. Okay, perfect. So you also have an unfavorable hours variance. So maybe you have unskilled workers, maybe you paid overtime, and so total variance, you would just add these two together, you would have 4,800 unfavorable variance. Let me read you what the textbook says. Labor rate variance, since it's unfavorable, the actual average wage rate was higher than the standard rate. Some of the possible explanations include increase in wages that has not been reflected in the standards, unanticipated overtime, and a shift towards more highly paid workers. So maybe you have more skilled workers that you have to pay a higher rate. The labor efficiency variance, the $800 unfavorable. Since it's unfavorable, the actual number is greater than the standard. As with other variances, this could have been a number of factors: poorly trained workers, poor supervision, low quality materials, requiring more labor time to process, and machine breakdowns. Yeah, so these are some of the factors that could be playing a role in your efficiency variance. So this is our efficiency variance over here, and this is our rate variance. And that's it for this video.